Welcome back to part 3C, which is the third episode, the third subpart of the third episode. I remind you that the third part is more focused. It doesn't deal with programming in a very marginal way. It is more focused on installing the operating system, installing the applications we will need, and then also something about networks and other things. In fact, we see here, this is the first part, the second part that we've already seen. The third part, so in the third part, we saw the system installation, the application software installation already done, and now the last part, mainly on the command line terminal. So at this moment, we start part 3C. So how do we proceed? We start again from the top. So you see these are two machines. I just moved the windows a little, so I would say we can put them in full screen. Then we put this here. And instead, let's send this other one to full screen. Perfect. After that, now we open another command, not a command line. Okay, we put it here. So we have a tool that can always be useful. We do the same thing under Linux. You see, I had actually already done it. All right, just a moment. Here we do something like this so that we have a slightly longer command line. All right, let's say that we can start. All right. So the first thing I would like to do is talk a bit about the command line and its features. So for example, if you want, take what the Explorer does. You see that here we essentially have the system at our disposal. So we mainly deal here with disks that nowadays are very often mostly imported in solid state form. So it's like they are large USB flash drives, but actually, especially on server class systems, they still use the previous technology, which involves magnetic type storage on media kept in rotation by motors on platters. It is a technology a bit old, but extremely reliable. Well, as we were saying here, how do we figure out where we are? Okay, so if you see, we go to disk PC, you see it says disk C, disk D. This was the Decades edition. If we double click here, we have our drive C. Okay, good. Then let's try to better understand how this thing is organized. So let's say that under Windows, because in this case we are dealing with Windows, we have, for example, a drive C. Then here's the backslash. This is called the root of the disk. Then under the root, there are branches. Let's say you can see it as a tree mounted upside down. Okay? The number of branches is known in the sense that one can put more or fewer, depending on many things. And sooner or later, you obviously reach the leaves of this tree. Okay? Let's take an example. You see, if this is C, what are the names of these nodes? Okay? So you see, since we are in C, you see that here it says C colon. These are the names of the various nodes. Let's take only two users and Windows. First of all, how many are there? There are 6. And two of these are users. And Windows here, we had put only 3, 4, 5, and 6. Okay. So we call this one users and this one Windows. Okay, 1 and 2, very good then. Sorry. I always get confused. If we now, for example, go inside users, you see that there's I and user. And so here, let's say that I obviously only draw one incident part here. I keep making mistakes here. On this side, I can draw I and user. Okay. And then here, let's suppose we double click at a certain point. you see that I have everything related to the user, including, for example, desktop. Okay, so here there will be another entry, and here there will be desktop. Okay, well, if I double click here, you see that we are actually on the desktop. In fact, you see these are the files we downloaded earlier, and so we have arrived on the desktop. Now, if I go back one step, for example, just click here, we're not on the desktop, we're on the user. If I open the command prompt, you see I typed cmd in here, and it found it for me. You see it writes C users IE user, okay? Now, you see us users, IE user, okay? So we are here at this moment, okay? And we are here, and we are here, also here, with the Explorer. Inside, there is the desktop. Well, at this point, exactly as we see the list of files here, if we want, we can see it from this side with the command here. Okay, if you check, in fact, the same things are here. You see videos, pictures, OneDrive, music, and so on. Okay, they are exactly the same. Now, however, I want to go look at the desktop, as we saw before. I double click here. How do I do the same thing here? I use CD. CD stands for change directory, D. Then, for example, I just write D and then press tab. You see, tab gives me some options that are not all what I want. So I press tab many times until I find desktop, or I write desktop. At this point, if I do dir again, you see that now I really see what I need. Now, two things. First of all, I moved forward. Let's say I proceeded in this manner, going like this. By doing from C, I did CD users, CD EA user, CD desktop. And if I want to go back, so if I want to go back, for example, I'm in desktop and want to return to EA user, I can go, I still use the command CD, but I use a special directory. You see that here the dir command shows me a whole series of things. Then it shows me 3 directories. One, which is first, which was the project we had created with code blocks. And the other 2 are directories, 1 double dot and 1 dot. The dot directory is a way to indicate the directory itself. So if I do cd dot, nothing has changed. It's not very clever, but it actually has a series of important utilities that we won't see here. If I want to go back, I have to use the dot dot directory, because the dot dot directory indicates the parent directory of the current one. In fact, you see that we are back here. So basically, it is like, for example, we are here, we do cd dot dot, we go back, we do cd dot dot again, we come here. Let's try it. Okay? So here we do it again. You see, another thing, exactly as we saw before, with the up and down arrow keys, I can retrieve the history. So, for example, if I want to do cd dot dot, again, I retrieve it with the up and down arrows until I find it and execute it again. You see that we are in users. But I can still go back by 1, and you see that I am in C. If I type dir, this is the root directory of my file system in all respects. C is essentially the hard drive. However, very often disks under Windows are partitioned, so they are divided into various disks. For example, there might be disk C and disk D. If you insert a USB stick, the USB stick would be mapped with another name, for example D. And so essentially here, assuming you insert a USB stick, you would have a second disk, okay? And inside here, intan, it could have a series of things, okay? And it could be the USB stick. We don't have the USB stick right now, but we saw that if we go here, you see that there is also the disk D. Disk D is purely random. It's a virtual disk, which is what we needed for the guest additions. And let's try to see what's inside. Ah, well, careful, not here. It's better not to venture. Yes, let's try here, let's try here. So, if I want to change the drive, I do D colon enter and I change disk. If I type D, you see this is the content of the disk. So what happened? What happened is that when I double click on it, I actually presumably launched this or this automatically. You see here it says auto run. Anyway, let's not dwell on that. What matters is that I have a second disk called D. And here too, for example, this directory corresponds to an operating system no longer in use called OS2. If I do D, you see these are the data of, okay, if I do CD, it gives me the current path, that is the current path, which is D colon OS2. If I now do C colon, I return to the previous path that is on the disk C. So for example, if I do dir, I do cd users. Then if I want to go forward, I do backslash and put IE user. Okay, you see that I did two at once, and then I do cd desktop again. Okay, and we are set. If I now do drive D, you see that I return to the directory where I was before. If I type C colon, same thing, okay? I don't lose, so to speak, my pointer. Now, so let's say here we have seen the cd command, which allows me to go up and down, and the dir command. If I type, for example, dir space dot dot, I do a dir of the previous directory, so in this case of EA user, okay? In fact, you see that desktop is visible. If I, for example, did dir dot dot backslash dot dot, I would do the dir of users C, the public users. But if I did it this way, I would do da of C. So this here, from here to here, is called a path, and in particular, this is a relative path. All relative paths start without the backslash because they are relative to the position where I am. Otherwise, I could achieve the same result, that is, see the contents of the root directory of the C drive by doing dir backslash, okay? Because in this way I see the root of the C drive. Why the C drive? Because I am in C, okay? And if I wanted, I could also do something like C colon backslash, okay? Otherwise, I could type there D colon, and this way I see the content of the D drive, okay? But generally, something like this is an absolute path because it starts with a slash. Otherwise, I could type D, okay? Then what could I do next? Users, okay? Here, of users, okay? In this way, you see that I did the dir of an absolute path because it starts with a backslash, okay? While relative ones have various characteristics but never start with a backslash. Well, so we have essentially seen the commands cd and dir. Okay, so I would say that the first thing to do is to see the same thing on Linux. I just want to remind you of one thing, in case you didn't know. Here I focused, let's say 50-50 between Linux and Windows, because Linux, generally Unix, is probably the operating system you use the most. You do not know it, or actually I think you know it, but if you do not know it, I am telling you now. Let's say a good 99% of mobile phones, tablets and things like that have operating systems based on Unix. For example, Android is a type of Linux, okay? And iOS, which is Apple's operating system, is a Unix, because when Apple developed its operating system, it was based on a particular Unix, a type of Unix called BSD. So let's say that since there are many more smartphones in the world than computers, Unix is definitely used much more than Windows. It's just that people probably don't notice it that much. Moreover, from a university standpoint, Unix is extremely used. And on the internet, the majority, let's say, as far as I know, almost all servers are based on Unix. So from my point of view, it is very important that you also have these basic skills. So you see here, the screensaver has activated. So just point downwards, click, and pull up this sort of curtain. Let's redo the test. Perfect. So we have seen how the file system works under Windows. Well, under Unix, it is almost the same, where almost creates problems. So, for example, I want to know which directory I'm in. On the other side, I would have used cd. Here I have to use another command called pwd. Do you see another difference immediately? There's a slash. On the other hand, I had a backslash just to complicate people's lives. Also, there is no disk name. It's simply not there. So even if you insert a USB stick, there is no second disk. There's always only one. So let's go take a look. On a sheet of paper, how the mechanism of flash drives works. So let's say it works in this way. Under Unix, you have a single file system that starts with a slash, which is the root. For example, something like this, it's made in exactly the same way, okay? Also the dot directory. The dot directory is the same thing. Keep in mind that obviously the Windows system was created well after the Unix system, because the Unix system is from the late 1960s, and the Windows system derives from a DOS system that is from the early 1980s. So it is obviously later. Actually, the designers of the DOS system, very likely, at least that's what I read, but I am not entirely sure, that they used the backslash because one of the designers who had developed Windows and also for DOS was a person who had worked at Digital. And there was another operating system, which was the WMS, where the separator was the backslash. Events that happened many years ago. In any case, this is the path, for example, of Unix. So let's say I now insert a USB stick. Okay? If I insert a USB stick, where will it end up? So within the system, I won't have a second tree. There are special directories within the system. For example, there is usually a directory called /mnt that, as the name suggests, stands for mnt. So what happens? Let's suppose I have a file system of a USB stick. Now what happens? This USB stick is inserted into this tree, as if you were grafting onto a tree. Are you familiar with how trees are grafted? To graft different types, for example, of cherries. So what do? Essentially, it's as if I erase this, and in its place, I put the other directory tree. So this is grafted in there. After that, when for some reason I remove it, and to remove it, I do the equivalent of eject, which is an operation called unmount. These three branches disappear, and the two underneath reappear. It's as if I remove the branch, and it reappears, and the underlying branch reappears. For everything else, fortunately, it is actually very similar. Only the commands have a few small differences. So let's look at these small differences. Now the command CD is also used to go up and down. To go to see what's there, the command is not dir and ls. Now ls alone doesn't show you much, but if you give it options, for example -l, where L stands for long and L stands for all, you see that I see many more things. You see that they don't fit on the screen. So how can I do? I can view one page at a time. So if I want to view one page at a time, I take this list and send it to another program that shows me a little at a time. Okay? This vertical sign is called a pipe, and it means that the output of this program ends up on the input of another program. And this other program is more, which is called a pager, precisely because it shows the pages one at a time. So if I do this, you see that I see. Okay? Then I, for example, press the key, return. And you see that I go one line at a time. Otherwise, I press the spacebar and see one page at a time. And at this point, I see everything. For the rest, it's all the same. For example, I want to, see I'm here inside home test. So I want to go to the root. How do I do it? cd /. Very well. So here, for example, note that underline works also for dir. However, let's say the best system is to use ls. Now, for example, you see these are all the subdirectories. So for instance, suppose I want to go into media, cd media. Then I do dir. Okay, then there's test. I can do a test. What do I see in here? But then there's something strange. You see, this looks like something that might interest us. So if I run a command called mount, I discover this thing. See this? See, type ISO 9060. They are the guest additions, exactly like in Windows, where an additional drive called D used to appear. Okay, here there's an additional disk, but for the reason I mentioned before, it's not a new disk. It's simply a part of the file system that you see here is mapped differently. For example, if I double click here, hoping that nothing strange happens, I didn't manage to. Anyway, here it is. I did it. You see that see if I do, you see it says it must be 0. The physical device must be 0. Ignore it. It is mounted up here. So it is inserted as we were saying before. We want to go inside. You see I am already in media test. So I can do VBox. VBox. Okay. I press enter. Then I type ls, and you see this is nothing but the content. The exact same content. The color indicates various things. Okay? And it's simply called syntax coloring. Anyway, apart from this, we have exactly the same things. But it is very important that you understand the basic difference between the two file systems. That is, one is based on a single tree, Unix. The other is based on multiple trees, one for each possible disk. Okay? This is absolutely the most important difference. The command cd, given alone, under Unix, while on the other side it would tell you the current path. The command cd under Unix takes you to your home directory. Be patient, the world is beautiful because it is diverse. Very well, here too there are absolute paths and relative paths. For example, I want to go into media test VBox. How can I do it? So I use pwd. And I am in home test. Then I would like to do a relative path. I use cd, so I need to go back by 1. And so I go into home, then go back 1 more. And thus I go to slash, then I can do media. You see that at this point, if I press tab, it already expands it for me because it is creating the path for me. Then I can do test, and then I do VBox. Okay? And this is a cd with a relative path. Relative, because there's no slash. It's the exact same concept. So let's say it's all very similar. There are some differences, but not very significant. Once you get the hang of it, you don't even notice anymore. In fact, I often use commands one on top of the other, make a bit of a mess, then realize it and use the right command. However, I would have under Unix, if I type cd sounds, it takes me to the last path, the previous path. Under Windows, as far as I know, there is nothing like that. Now, I would like to try doing the same thing with an absolute path. If the path is absolute, it begins with slash. So what do? cd slash. So at this point, I take this path here. You see? For example, I could write it directly like this. So I can do media, test, VBox. Okay? And here we are. So once again, I remind you, relative paths, absolute paths. The difference is very important. Now let's go back to our home and then go to our desktop. Okay, this is our desktop. So if you see, there is a folder called Primo, which is the one created by Code Blocks when we did our small example. Let's go check on the other side. To go to our home, in this case we do cd dir, but we needed to go to the desktop. We do dir, and you see we are there. You see that here too there was the directory called Primo because we named it the same way. Let's enter the Primo directory. Okay, you see it says bin, which is a directory, main.c, obj, Primo cbp, and Primo layout. This is the file that describes the project, okay, CodeBlocks project. Obj contains the object files. You will see it later in the course. Main.c is our .c file. If we do more main.c, you see our .c file. Even simpler than what we saw before. Inside bin, there are bin stands for binary. So if we do bin, we go here, we type dir, And you see that then there's a subdirectory for debug. Due to the fact that we, however, all the things you'll see, dir, you see this is primo.exe, okay? If I type primo.exe and see, I launched it, and thus triggered all the effects of my program. So the second extremely important thing is that to launch a program from the command line, it is sufficient that I type its name. There are other operating systems from the past where to run a program I had to write something like run primo.exe, which really gave the idea that you were launching the program. Now inside Windows it is not necessary. Same thing inside Linux, so we do the same thing. For example, let's go inside Primo, okay? Always notice the slash instead of the backslash. Then we do ls. You see it's the same because code blocks obviously works the same way. Now for example, let's try to do more main.c. Same thing. There is also another command called cut, which does the same thing. Alright, more or less obviously. Here we don't have time to get into details. Let's go into bin. You see I don't write anything here, I just press tab. It expands it automatically because there's only one choice. Then we do ls. If I do lsla, it tells me that it's an executable. You can tell from these codes, but let's not worry about that. So if I want to execute, I could write primo. First of all, there's no extension. On the other side, you can see it said primo.exe, where exe clearly stands for executable. The extension is characteristic of DOS and thus Windows systems. Under Unix, they are not necessary. They can be added, but they are not necessary. In fact, very often they are there. So if I now write primo, something strange will happen. You see it says primo command not found. But how is it not found if it's there? Well, it's not found for the simple reason that, for reasons we won't get into here, for reasons of computer security, in the standard path. So let's say within what the system searches when I launch it, it is not included. So what do? I tell it to look in the recurring directory, period. So the direct recurring period. Then I add a slash. There is a file called primo. Now you see that it liked it. So an important concept, if you want to launch a program, you simply have to proceed by writing the name. Attention, this applies to compiled programs. When we will very briefly see Python programs, you will see that Python is an interpreted language. And so when you want to run a program written in Python, you have to launch it somewhat like I mentioned before. But instead of saying run primo, you will need to use Python. First, something like that. Okay? Very well. Now we still need to say a few commands. So first of all, let's return to our position and go to the desktop as it's always convenient. Okay? So let's also go here to the same point. cd dot dot. So cd dot dot. And we're also here on the desktop. Okay? Good. Now we want to create a directory. Let's do it. So to create a directory, there's a command called mkdir. And so we'll call it whatever. Please no spaces in file names. This is absolutely essential. It's a fundamental rule. Okay? I understand that you are used to putting spaces in directory or file names in Windows. It's a bad habit because unfortunately it conflicts with various internal problems of operating systems and sometimes creates serious issues. Every year with code blocks, every single year, I encounter people who have problems that I'm not describing. They are really strange. Really strange due to the fact that they have put spaces within the directory names. We created the directory. Very good. cd testdir. I just press tab and here we are. Same thing here. Okay? mkdir, same command. Testdir. Okay, I made a mistake. You see, I wrote provadir. All right, let's change its name. How do I do that? Well, under Unix, I have a command called movemv. Move obviously moves, okay? So if I do provadir, and then notice it automatically added a slash to indicate it's a directory. Now if I press tab again, you see it rewrites provadir, but at this point I change it and set it to provadir. And you see that here it has obviously changed too. So we've seen another example. Let's see the same thing at this point. Go back by one and try to rename provadir. Okay? In this case, let's try with
Command is ren. So let's do it like this. Ren provadir in provadir2. So I do something like this. You see that now it has changed. It has become provadir2. Now let's do a little exercise. So we have seen that inside Primo. We go inside Primo. Actually, let's do this. Let's do dir Primo. Okay? So I am still in the desktop and I do dir of Primo. You see that here is main.c. Now I want to copy the file main.c into provadir2 while on the desktop. So what do? I copy the command under Windows and copy. Now I need to find it inside Primo. So Primo, okay, backslash, then main.d. Where do I copy it? I copy it into another directory called provadir2, another relative path. So provadir2c, it recognized it also because it's the only one that starts with provadir, and that's it. I copy it in there. Okay, if now, for example, I go here, sorry, let's go directly to the desktop. I go inside provadir2 and you see that I got this thing. Let's briefly do the same thing, but you should have understood that it's very similar. So I'm going to copy here. The command is cp, slightly different, cp primo, main.dis in provadir, done. Now we do ls provadir, and you see that the file main.c is there. Now notice that we have copied. So copying means making a duplicate. Now let's go back inside provadir and try to delete this file. How do we do that? The command is rm, which stands for remove. Okay? I just pressed the tab because there was only that file there and it deleted it for me. Now we go here and want to go inside provadir2. We have this and we want to delete it. The command here is del. That's all. If we want, we can also delete the directory. Let's go back. And we delete the directory with the command called rmdir. The rmdir command also applies under Unix. So we do rmdir provadir. You see that the icon here has also disappeared correctly. Well, I would say that I am consulting here. Okay, I would say we've covered the major part. Now we need to create, let's do an example where we create a file. So let's go again. Let's recreate the directory provadir. Provadir. Let's go inside provadir. Very well. Now let's create a file. So there are various editors. The one most used, let's say I use another editor because I'm accustomed to it given my age, but usually an editor called Nano is used. So for example, test.txt. So now I will edit a file called test.txt. You see that here I can write whatever I want. Then when I've decided that's enough, I press Ctrl X. Okay, it tells me save modified buffer. Yes, so I need to press Y, find name to write test.txt. I press enter, and we are all happy. You see, if I do cat test.txt, I am very pleased to have created this incredibly interesting file. Now let's get back here, and we do the same thing. Once upon a time, in DOS, there was an editor called edit, but it's no longer there. So at this point, what can we do? Let's go get Notepad. So keep in mind that Word might do the same thing, but the file.doc, as you will see in the course, contains a whole series of metadata, so it cannot create a purely text file. Instead, Notepad can do it. So for example, this, and a test file. Okay? Very well. At this point, we save it, we do save as. Okay, where are we going to save it? Let's save it on the desktop. And then let's go, since we were interested. Okay, let's create here. test dir, like before, test dir. You see that here the icon provadir has appeared, and we are going to save it here. You see, I want it to be of type txt find name, so it was test txt. Okay, save. Perfect. Now from here we do dir, we go into provadir. Here we are, there it is, test.txt. Now here cat doesn't work. If I do more, you see that here we have done exactly what we wanted. Well, let's say that all in all, we have seen the basic thing you need to then manage the terminal better, which is very important. Unfortunately, as I was saying, are skills that are usually lacking. I'm just checking to make sure I haven't forgotten anything. Yes, I would say we're there. Well, now we can close this and move on to something that is indeed more interesting. So this virtual machine, as you see it, just like the other one, is connected to the internet, because we clearly saw that when we needed to download something, we went online with the browser, downloaded what we needed, and did what we had to do. So if it is connected to the internet, it means it has an IP address. Now, we're not going to investigate how addresses are made, because it would be a very complicated topic, but you absolutely need to have a minimum of training. So what an IP address is, you probably already know, because we all have the internet at home. However, it is important that we also look at it from a slightly more formal perspective. So how do we see what IP address we have? Well, on Windows, we can use a command called ipconfig, to which we then give a parameter called all. Now you see that here it is. Let's try again. So we have it all in full. Perfect. So you see, what is the IP address here? Now, the IP address here is this, 10.0.2.15. Okay. Let's see on Unix. On Unix, the command is different, just for variety, and it is called ifconfig. Okay. Ifconfig stands for interface configuration. Here it is, 10.0.2.15. But how is it possible that they have the same IP address? The IP address is by definition unique. Always they have the same address, because these are special addresses, those that start with 10. Just to give you an idea, the addresses of the Polytechnic University of Turin start with 130.192 dot something, and they also consist of 4 blocks. Each block is a number ranging from 0 to 255. So in total, there's a huge number of possible addresses. Well, then these are particular addresses, those that start with 10, so-called private. So this means that VirtualBox, besides doing everything we have seen, also manages the network. And therefore, this means that when it manages the network, it generates a private network for each virtual machine. So each of these virtual machines has its own little private network where it does what it needs to do. But we would like to put these machines in communication, right? That is what I would like to show you. So how do we put them in communication? Well, if you remember, we set them up to work as NAT, which is fine for everything we have done so far, but not good for what I want to do now. So what are we forced to do? We are forced to change this network model. We certainly don't have to reinstall, but we need to reboot. So we have to shut them down, okay? Shut this one down, then we have to shut down the Windows machine, because it obviously has the same problem, because the issue is neither with Windows nor Linux, the problem is with VirtualBox. You see, we always have some little problem here, but that's another matter. So now while he's thinking about it, we'll go under Windows, okay? Powered off, okay? Both are set. Now let's go and see inside settings, for example, of Windows. We go into network, and you see it says NAT. Well then, what other possibilities do we have? Well, we have quite a few, you see. So, which possibilities interest us the most? Obviously, I have already set this aside for myself. This is the manual, sorry, it's the VirtualBox manual. In particular, it is chapter 6 of the manual, the one concerning the network. You see that here, we have various possibilities, and every plus sign indicates something that can be done. For example, the virtual machine can communicate with the host, so the guest can communicate with the host. I remind you that the host is the physical laptop. But I would like, you see, that the host cannot talk to the virtual machine. It can talk. In short, the points, you get it, right? I would like the two virtual machines to be able to talk to each other. And you see that NAT does not allow this possibility. In fact, we just discovered that the IP address is the same, so it cannot be done. But you see, we have others. Now, let's not get into details here. Of course, if you want, you can go and check it out. But let's say that the simplest way is this. Because here, using NAT service, we also have the possibility to continue going on the internet. Something that otherwise here is not said, is not possible. There are a whole series of possibilities. These possibilities are extremely well studied and allow you to do a whole series of things. Because, for example, you might need to create internal networks that have different levels of security. And so you might not want to be able to do certain things. However, here we do not have problems, so we must choose the NAT service mode. Well, let's choose the NAT service mode. Now, the NAT service mode, you see that here it is called NetNet. But there's a problem, and I can't do it here. This name is essential. Why is that? Because this NetNet works if I define a network name first. And I have to define this network name directly at the level of VirtualBox. That is, I have to tell it, look, I want to create a network. Of course, I might have more than one. For example, I could have 10 virtual machines, 2 communicate with one network, another 3 with another, and so on. In this case, we only need one. You see, I do NAT networks, and I do more. And you see that it creates one for me. The name is that one, it's fine with me. So I do this. At this point, I get here. I go back to network, do NAT network, and you see that now the name I want appears in the list. So we are set. I do the same thing under Linux. Network, nete, network. It appears the same because clearly I can choose to connect or not connect that virtual machine to that network. I want to do it, but I could also choose not to. Very well. I remind you that, for example, there are 2 other virtual machines here that are currently turned off, which I use for my reasons, and they have nothing to do with it. Very well. So these 2 should be fine. Let's check, because I don't want to have made a mistake. Network, perfect. Now we can restart both of them. Now at this point, what happens? That when the moment comes to go on the network, VirtualBox will provide them with a different service from before. While before it provided a service where each virtual machine had its own network, all its own, completely private. Now there will be a network, still private, but for 2 machines, which are the ones I assigned to that network. And additionally, if desired, there will be other networks. For example, if I were to start other virtual machines, I could obviously do that, and those would not be in that network or in one of the many other modes we saw earlier. Okay, in the meantime, I'll also start up Windows because this phase is always a bit critical. Okay, this woke up without problems, and I am pleased about that. Okay, so I'm going to put this there. This is Windows, wanting to know if it should go full screen. Bear with me, but this is an important step because it is extremely interesting. We're almost there. We can turn these off. Okay, let's start looking from Linux, since it's already started. So here we write terminal. Very well. So we said to zoom in a little, Ctrl+. Then, if config, there it is. This is the same. Now I expect the date part to be different, otherwise it's a problem. So pass with a capital P, W0, RD, exclamation point, go. Okay, it worked. So here we do CMD. Very well, ipconfig. There you see It doesn't find the keyboard anymore. Okay, let's fix it. Italianol. So address, here it is. You see 10025A. Over here, it's .15. Now, how do we make them see each other? How do we make the machines see each other? There's a command called ping. It's like touching the other with a finger. So over here, there's the 5, and over here, there's the 15. The prefix is the same, so 10.0.2.15. Here, you see the Unix machine is responding to me. You see, reply. Now, let's try going over here and try to ping 10.0.2.5. And this one, however, is not responding. How is that possible? So maybe there is some other problem. Let's do it like this. Let's do another experiment. So another way to connect is by using a command called SSH. Windows 10 has made significant progress because SSH exists both as a client, which we will use, and also as a server. Moreover, there is a whole series of tools taken from Linux that can be adapted. The functionality is definitely good. So we can do SSH, which is a way to connect to 10.0.2.15. Here it is. So you see that the Linux machine has responded. It asked me, are we sure it's him? Yes, we are sure. Okay? And now it asks me for the password. But the password is for the user, EA user. So even if I give it the password, which is test, it doesn't like it, obviously. So what do? I press Ctrl-C. Then instead of doing SSH this way, I write test here, and then I put it here. Here is the E of ETA. At this point, that is the name of the user on the other side. At this point, I do test. It worked. Now, at this moment, I am connected to the Linux machine. Keep in mind that we are on 2 virtual machines here, but I could be on the other side of the world. And if I give the command ls, you see that I am looking at the file system of the other machine. If I run a command, whatever type it may be, if I use CPU, for example, the classic command under Linux is stop, it shows me how many processes there are, how much free memory there is, and so on. I am running it on the other computer, which by the way is the same here because these are virtual machines. If I want to exit from here, I type exit and return to my machine. You see, connection closed. So I cannot do SSH from this side, meaning towards the Windows machine, because the SSH at this moment, Windows does not have the SSH server active, because the SSH is a protocol, and as generally in IT, we have what is called a client-server system, where we have someone providing the service and someone using it. For example, if I go to a website, I am the client, and the web server is indeed the server, the one providing the service. When I do SSH here, for instance, I am the client because I use the service, and the service is provided by this other machine here. Now, the Windows machine is not able, as configured, to provide the service, while the Linux machine can, because we have installed, among many things, Open SSH Server, which is exactly this. This is why we installed a whole series of things. For example, NetTools was needed for ifconfig, etc. Very well. Let's try to understand why Windows is not responding. So we use a command called nmap, okay, that we installed earlier. And let's try doing VA. VA. And then we give it the IP address 10.0, 0.5. Now he's trying. So what is nmap for? It's something called POSCAN. It's a bit like knocking on people's doors to see if they are home, if they are at home. Now keep in mind that he doesn't find anything and says lost is down, meaning it seems to him that the computer on the other side is off, or since it is a bit suspicious, it says it seems down. But if it is really up, if you know that it is really up, it means something is wrong. There is something blocking our attempts to analyze the situation. Keep in mind that post-scan is considered a hostile activity. So if you do a post scan on someone who is not expecting it, that person might get upset. In this case, it's clearly a testing environment, so there are no issues. But I need it to help you understand how the system works, because it is actually used for that as well. So let's go this way. Let's see if we can figure out what might be causing this system, this problem. It could be the firewall, because Windows obviously has the firewall and Linux has it too, obviously. So let's try to disable it. So we disable it, turn off. Okay, I deactivated it. You see that it gets a bit upset. It says be careful because this is not a smart thing. It's right. But okay, now let's go back to this part again and redo Nmap. Well, since we lowered the firewall, you can see that at this point, Nmap finds a lot of things. You see, there are so-called ports, TCP ports, that is, open connection ports. For example, let's try ping. Now it responds. So this means that before it wasn't responding because the system was blocking all access attempts. So this is an experiment we conducted. Now, still within the scope of these experiments, there is a command under Unis called netstat, which, as you can imagine, stands for network state, netstat. If I do netstat pipe more, it's deadly. To show it, demonstrate it page by page. You see that here I have, you see, this indicates the state of the connections. And in particular here, it tells me, you see, it tells me that on the SSH port, it says listen, that is, it is waiting. Now I do Q to stop it. Then I go over here and relaunch the SSH from before. That is the SSH with which I had connected. I reconnected, and now I'm trying again with this netstat. You see here, there's the SSH. Look closely, because now it will change. Here it is. See? SSH established. It means that someone is connected from the other IP address. So netstat, now I've mentioned it very quickly, allows you to see. There is a lot of information you can see. It allows understanding the current state of the connections. Well, so let's see. So I've done this. Here I have my little program to run. Perfect. Now the last thing I want to show you is twofold. So first of all, a little game. So if we launch a program here, for example, ls is a program, just like our first one, but there are also graphical programs with graphical output. For example, Firefox. You see, I launch Firefox. It gives me a few various warnings, and then it shows me Firefox in operation. Well, now I can close it here. Is out of date. Okay, all right. Close tabs. Perfect. We did it. Okay? You see, at this point, it returned to the starting point. Okay? So if I launch, as I was saying, Firefox, I launch it like this. You see? It starts. But at this moment, let's forget what Firefox is doing. And come on, let's go. If I go here, you see that if I press enter, nothing happens, meaning the terminal is stuck. Okay. All right. So is there a way to avoid this problem? Very well. Now, if I do Firefox and then put an ampersand here, it means take the Firefox and launch it in the background. Okay? In this way, it starts and does what it needs to do. Okay? But I still have my terminal free, you see? And I could even launch another Firefox, you see? And then yet another one. It's not an issue, apart from the fact that it doesn't make much sense. Okay? Very well. So this was just to tell you this thing. But now one last thing, that in short, I hope it's interesting. My purpose here is to show you some things. I press enter. You see, it tells me done because I am finished. My purpose here, I need to show you some things that I find interesting, so that maybe one of you might say, Ah, this is cool. I want to try it too. Okay, and to try it out, maybe you'll go look for documentation, because of course all these things can be found on the internet without any problem, clearly. Well then, here I want to do something, so let's go back here. So we'll close this one, we'll leave this one in place. Let's relaunch Firefox and hope it doesn't cause problems like last time. So we have seen that the Linux machine also has servers. For example, the SSH server. No, please, no. Okay. It also has various servers, for example, SSH. So my question is, could it be a web server? No. My Linux machine, we've seen it has the address 15. Okay. So if I write here, no, not here, 10.0.2.15. And it means that I am addressing the Linux machine as a web server. Okay? And no, it tells me unable to connect. Okay, good. So this means it's not a web server. Well, it's not like we can't turn it into a web server. Yes, of course, I'm making it very, very simple here. But let's try to install, you see, with the usual system. Install Apache 2. Apache is the typical web server for Linux, even though it's not the only one. It asks me for the password for self-authentication. And the installation of this object also enables the server, okay? Because naturally one can enable it, disable it, do whatever is needed. Okay, great. Now it is doing its job. It is installing. It won't take much longer. Fortunately, quite fast installed. Let's go to the other side now. Let's reload the page. Okay? Or you see that the web server works in the sense that the Windows machine queried the Linux machine asking if it was a web server. And it said, yes, I am a web server. This is the default page that naturally serves just to show it works already. But you might say, I would like to do something serious with it. Okay, we definitely won't do anything serious here now. But you see it says that the file, this file, is this one, var www.htmlindex.html. I remind you that this is an absolute path. All right, let's try it. Change directory to var www.html. Okay, if I now do more index.html, this is the corresponding HTML file. You see, but I am not interested. So I want to create another one. So what do? Sudo, because these are root-owned directories, move index HTML to old index.html. Basically, I change its name. Okay. All right. Now you see it's no longer there. At this point, I create a new index with nano, but excuse me, I always have to use sudo, otherwise it won't work. HTML. Okay, and here I write this. And a test of web server period. Then I save it. Control X, save modified. Yes. Okay, you see that now there's the file. If I do more index HTML, there's simply this part because the text is a subset of the HTML. Well, if I reload again, you can see that I have uploaded the new web page. So if I wanted to create a really simple website, because today a similar thing is not enough, this would be the solution. However, keep in mind that many very old websites, for example mine, are made exactly this way. That is, with single files, written, of course, in HTML that contain what is needed. Well, I would say we've done everything, so now I'm only missing one thing. First of all, since I hope, I expect, but maybe some of you might want to go deeper, so I tell you that a good place to find excellent documentation is this. These free computer science notes, written in Italian, are truly an encyclopedic work. There's everything in there, particularly on this subsite, which is essentially their SAS. There's everything. There are a lot of things that can be useful and can also be useful for the course. In fact, I usually recommend it for the course. It's not the textbook. But there's infinitely more than what we do in the course. There are also very different things. Very well. Now, the only thing I still have to do before closing and give you an exercise, as we have usually done. So keep in mind that the first exercise you need to do is to reproduce everything we have just done, which will require a fair amount of effort because things don't run so smoothly. And as you may have also noticed, very well, let's do the following exercise. You need to do it both under Windows and under Linux. And if you have a Macintosh, you can also easily do it under Macintosh, considering that Macintosh is fully a Unix system. You just need to look for the terminal within Applications. Inside you'll find Terminal and launch that as it's the equivalent. Now, I would like you to create, for example, go to the desktop and then create a directory tree. Okay, sorry, not much focus. Okay, create a directory tree. C of a very simple exercise created a directory tree. So with mkdir, and what we need then, go into C, and here inside create a file with Notepad or Nano, depending on whether of the operating system you are using, and create a file called pipodot. You know that computer scientists often use these names, pipodot.txt. Okay, and inside you write something. Then you go into A and write the command to copy the file that was in CE to copy it to the... Okay, something very simple. You do it with both absolute paths and relative paths in order to have, let's say, a minimum overview on this thing. Well, then, I would say that essentially we have finished this part, which was strictly related to the installation of the system and the use of the system. So we'll end here and see you for the 4th episode, which will mainly be on the comparison between Snap and C and Python.